Let's move to bond calculations. This is probably newer to most of you, although our finance students have spent some time with this. Let's talk about bonds. First, let's read through these definitions. Settlement is the date the security is bought by the buyer. Maturity is when they're repaid the amount. The rate, also known as the coupon or coupon rate, is the interest on the face of the bond that is paid to the buyer. Yield is the rate of return the buyer receives, including all interest payments and premiums or discounts. Redemption is the amount the buyer receives at maturity per $100 face value. In typical cases, the buyer gets the face value, so the argument is 100. The number of times per year that interest is paid is the frequency. It is very common for it to be twice a year. Let's spend our time looking at price and yield. First, how we price these. That depends on a lot of different things, but we need to understand bonds a little bit better first. Who authorizes a bond? If I'm in a corporate setting, then it's the board of directors. If it's a municipality, often the voters of the whole community will take a vote on the bond. And then the city council will go ahead and issue the bond. On the bond, we have a certificate, some of them are very nice, that will show the amount of the bond, its face value, the interest rate, and how often that interest rate is paid out, and the maturity date. How do they get the interest rate? They see what bonds with similar risks are selling for on the market currently. Risks include whether you're a city with a AAA rating or a AA or maybe a BB rating. You will have to pay less interest if you have less risk. Then the bonds are sent to the printers where they are printed up with that date, interest rate, and maturity date. Once they are printed, they are sent to a financial institution to make the sale to the buyers. But what has happened in the meantime with interest rates? This may be several days. That's right, they either go up or down. If interest rates have gone up in the local market, then your interest rate isn't as much as what's being currently offered. So nobody would buy your bonds, except they do, because the bonds are sold at a discount. That is for less face value than they're worth to make up the difference in that interest rate, so in the end it will approximate that same interest rate. If the interest rate has gone down and you're paying more than what is common, then the purchase price is adjusted by going higher, or we call it a premium. So if the interest rate is lower than our stated rate, we sell it at a premium. If it's higher, then we sell it at a discount. Let's see how this pricing works over here. In example 1, we have a purchase date of January 19th, 2009, and a maturity date of January 19th, 2017, 8 years later. The coupon is 8%. The desired rate, or what's going in the market, is 10%. The face value on the bond is $100, and the interest rate is paid out twice a year. What should those bonds sell for? If you notice here with price, I have these inputs, and I can see that because the desired is higher than the coupon rate, then we'll sell at a discount of $89.16. Example 2 is exactly the same problem, except the desired return is only 6.8%, so they are sold at a premium, $7.31. Let's have you work a problem down here below, practice problem. So Company X issues bonds with a $100 face value and a 10-year maturity date, a 6% interest rate, twice per year it's paid. How much should an investor pay for the above bond 2 years since it was issued? That is, you have 8 years to go and has a desired return of 7.5%. I've done the answer below, but try working it yourself and see if you can put those values in to get the right price. Note, I've also given a hint. The actual dates used for settlement and maturity are irrelevant as long as the time between the dates is correct. Go ahead and work it. It is important to practice these equations so you know where your limitations are or what you need to understand better. What did you have problems with? Yes, most students have problems with the actual dates and getting those dates incorrectly. Understanding dates and using them correctly in financial formulas is extremely important. I've had brokers call me wanting help from students to help them work with dates in their different financial instruments. Let's go and take a look at this together. You'll notice this first part of the equation. For the date, I've put in today's date. Now I need the second date that is exactly 8 years into the future. In this case, I've put today plus, and I've used the date formula, 8 years exactly. Now notice I had to put in 1 under month. That's on January 1st, 8 years later. What if it had been 8.5 years? What would I have done? I would put in 8, 7, 0, or 8, 6, 30. Either one would be 8.5 years later. Now I could have also put in any date I wanted. I would put it in quotes like 2/18/2020 in quotes, double quotes that would be, and then put an exact date 8 years later, such as in quotes 2/18/2028. Play with those dates and see that you can input them correctly. Okay, let's go on to yield. Remember that depending on the price, yield is the actual percent that I am receiving or paying out, as the case may be. Here I have a bond, the date purchased, the maturity date, coupon price, face value, and frequency. The price here is less than the face value. Therefore, you know that it's being sold at a discount. That will increase the yield that I get. On the other side, we have a price that's greater than the face value, so the coupon rate is reduced to 7.17%. Go ahead and try inputting this into this equation as well. The same investor as above, interested in buying the 10-year bonds with a 6% coupon rate paid twice per year. Note also this is 2 years into it, so there's only 8 years left, just like above. This time he wishes to pay only $93.95 for each $100 face value bond. Go ahead and work that and see if you can get the answer below. Again, the dates are the most important thing to figure out.